Okay, good. So today, let me share the screen now. Okay, so it's let's share this one. Good. And let's get the, just 1 second, I turn on also the phone so I can see what you see, because otherwise, let's see. Okay, good. Let me see. I just want to make sure that everything is working. Okay. 1 second, because I can't see my own screen. Can you see it? Can you please write on the chat if you see my screen, please? Okay, I can see it. No problem. Okay, very good. Thanks. It also came on my phone. Okay, perfect. So let's have a look here, and this is the list of the lectures. We have a last one, which is saltwater intrusion. I decided to indeed to focus on it. And you know, this course has been a mix of theory and practice, with I would say more theory than practice, but this is fine. I mean, the practice, I know that it's also taught in other courses, advanced hydro systems engineering, etc. But so it has been a mix with perhaps more discussion on the theoretical part and more discussion on the, let's say, on the policy making part, which is, as I said, it is fine, but still I want to keep some eyes on the theoretical questions, because I think it is important that you are aware, you are fully aware of the fact that at the end of the story we are talking about sustainability, we are talking about water resources, but at the end of the story it's an engineering problem which we are interested in. So I want also to take some opportunities to emphasize what is the connection between climate change and professional activity as an engineer, what is the connection between decision theory and the professional activity. So saltwater intrusion is another topic that it's technical, but precisely connected to sustainability and connected to climate change, for instance, connected to the circular economy for many reasons that we will see. So I thought that indeed it is an interesting part, and so let's click on this lecture, and which is linked here. Okay, this is saltwater intrusion. Let me get the web page which is larger. Okay, good. And just let me take a pen, because I will have some notes for sure to take. Okay. Okay, very good. Let me take a sheet, just 1 second, a blank sheet. Okay, very good. So, what is saltwater intrusion? I think you know something about it. It's strictly, let me click on the web page. It's strictly connected to water resources management, and it's strictly connected to human impact. So, what is saltwater intrusion? Saltwater intrusion happens in coastal area, but it may also happen in the coastal area of internal lakes. You know that there are some internal lakes that are affected by salinity, and there are some internal areas where you can find brackish water. So when you have the presence of inland of salt water, it's a problem. We already discussed last lecture we discussed about desalination, And we saw that desalination is frequently connected to the use of water in agriculture, and in particular it's connected with the use of water in close to areas where salt water is available, of course. And salt water we discussed last Monday, indeed, or let's say water with higher than usual salinity may be a bit of a problem in agriculture, and therefore when we desaline water we have to be very careful, because if we use water with high salinity, it's dangerous because the salt accumulates in the soil, making the use of this kind of water for irrigation not sustainable. And it's a bit of a problem because removing the salt from the soil is much complicated, takes a long time. So this is a kind of unsustainability that it's difficult to recover from, and therefore we have to pay particular attention. So the problem is there when you use desalinated water, if the salinity is still relevant. But the problem is also there in coastal areas where it may happen that you have the salt water from the sea that is intruding into the land. Saltwater intrusion is precisely the intrusion of seawater into freshwater bodies, which may happen because coastal areas, not always, but in alluvial areas, coastal areas are permeable, the soil is very permeable, especially in alluvial areas, as I said, because of course by definition, alluvial areas are formed with the deposition of sediments by rivers, and usually these sediments are very permeable. And therefore permeability implies that water can move in the soil, and so fresh water can move in the soil, which is a good thing, because in this way groundwater bodies are formed. On the other hand, also salt water can move in the soil, and we say can intrude because it's intrusion from the sea to the land. This is a problem because we use groundwater also for irrigation. So if it happens that you get from wells, you get salt water, this is a problem because, if you use it in agriculture, you end up with the same problem that we experience when using water with high salinity. Precisely after intrusion, what you get into the well is a mix of salt water and fresh water. So the result is water with increased salinity. And this is, as I said, a bit of a problem. It's a concern for the sustainability in agriculture. It's a concern for the ecosystems because salt water means that certain species, certain vegetables cannot survive after saltwater intrusion. It's also a bit of a problem for the animals, and because some animal species, they get a suffer if the fresh water where they live gets increased salinity. The problem with saltwater intrusion, it's the fact that it's okay, it's a natural phenomenon, which is fine, but also it is the result of human impact. We will see that human activities turn up into increase of salinity of the underground water. So the human activities may end up with saltwater intrusion. So why is that? We will see in a mathematical form what are the physical laws that dictate the movement of water, and in particular salt water in the underground. But before talking in math terms, before talking analytically, let's make a qualitative assessment of the drivers of saltwater intrusion. And here you have a couple of figures which are, in my opinion, interesting. Let me reduce the size if I can, or let me do this. Just 1 second. Okay. So what is this? This is a 2D graph representing some phenomena. These are basically drivers that can be partly induced by humans, partly natural, but these are drivers of saltwater intrusion in terms of their temporal and spatial scale. On the vertical axis, you see the spatial scale, and in this case, it is a scale ranging from regional to global. I will show you later second graph, which makes reference to the finer scales from local to regional. But for now, let's focus on this spatial scale from regional to global. And the time scale is ranging from acute to chronic. What does this mean? Acute means a single episode which evolves in a short time, which like a tsunami, for instance. You see that there are tsunamis placed in the time domain of acute events. These events are typically short in time and they are infrequent. On the other hand, if you move towards right, in the chronic domain, as the term suggests, it's the domain of phenomena that are long-lasting. Maybe they have lower intensity, but they have the problem that they are very extended in time. Now, let's look at these drivers. So you have on the left tsunamis and hurricanes. These are phenomena that you well know, and in particular, the hurricanes are usually a bit more lasting than tsunamis. Tsunamis are phenomena that evolve in the matter of few seconds. The hurricanes, as you know, can last for some days, and their spatial scale is typically a large spatial scale, but it's typically regional. Okay, and these phenomena, they are particularly concerning because they translate into coastal flooding. And coastal flooding means that you have this water that comes abruptly, violently into the land and goes into the wells and then introduces a large amount of salt into the groundwater bodies. And recovering, as I said, is extremely complicated. Once that you got a groundwater body that is contaminated by salt, recovery may require tens of years because the flow is so slow in the groundwater that recovering, which means washing the salt out, it takes a long time for the low velocity of the groundwater flow. I think a very interesting example of a phenomena like this is, I go back to the web page, is the other one. 1 second. I go back to the web page, as I said. Okay. Here I am. 1 second, I wait for the screen to adjust. Okay. So, as I said, a nice example is the tsunami that occurred in Southern Asia in 2004. And here is the link. You can see the link here. I am making a selection, but it is the blue link that you see on the screen. This is again a Wikipedia page. If you click on it, and I am now clicking, I see that the screen is a bit slow. It usually happens early in the morning, but it will improve. So I'm clicking on it. It's a Wikipedia page describing this tsunami, and I think it is interesting. If you have a look at it, this Wikipedia page is very descriptive, but it gives you an idea, first of all, of what tsunamis are. And I think it is interesting because when we talk about sustainability of water resources, these events are really a matter of concern. So I suggest that you have a look there. And I just want to mention to you that after the tsunami, there was an international cooperation that started with a lot of scientists involved to recover the aquifers, because these people rely on aquifers for most of their water supply. And after the tsunami, there were really a lot of concerns related to the recovering their water resource systems. So I think it is indeed an interesting example. So let's go back to our figure then. So these phenomena like tsunamis and hurricanes, they are interesting. On the other hand, there is to say they are interesting, and besides interesting, they really matters a lot. Really matter a lot. On the other hand, it is unlikely that in your professional life you will get to deal with them, because they are fortunately infrequent. If you move right in the graph and you shift to the more let's say the more frequent phenomena, the more chronic and then frequent phenomena, you get the droughts. The droughts affect saltwater intrusion a lot. I'll explain you why in the course of this lecture. And then climate oscillations. Climate oscillations, it's different than climate change. Climate oscillations, when you use this term, usually you refer to shorter scales with respect to climate change. Climate change is supposed to be something chronic. Oscillations, as the term precisely says, are supposed to be to refer to a time scale that it's shorter, and they are supposed to be reversible. Climate oscillations create problems, and I will show you why, but let me anticipate the reason. The reason is first sea level rise, which is something that can be indeed fluctuating. If you remember, when we discussed climate change, we saw some graphs about sea level rise, and we saw in the past 150 years a marked increase. But there are fluctuations within this increase. There are periods where we got a decrease of sea level. So these changes in sea level are very effective on saltwater intrusion, and we will see why. It's really interesting to see how even small changes in sea level can translate in very significant changes in intrusion, into saltwater intrusion. And also climate oscillations originate a second problem. The second problem is the fact that you can get by intuition that in order to contrast saltwater intrusion, you need a flux of fresh water from the land. Because on the one side, on the side of the ocean, you have salt water pushing to get into the land. And you know that water is heavy weight, and pushes a lot. So on the one hand, on the one side, the side of the ocean, you have salt water pushing. It's clear that what is opposing into the land, given that you have a permeable soil, when you are concerned by salt water, you have a permeable soil. What could be the way to oppose? The way to oppose can be either an engineering structure, or can be a corresponding a corresponding flux of water in the opposite direction, which is fresh water, because we know that in the groundwater there are fluxes of fresh water from the land to the ocean. This is clear. It's clear because on the land you have a higher elevation, you have water with more energy because it comes from an higher elevation, and therefore you have this interaction between fresh water that naturally flows into the sea from the underground. And on the other side, you have salt water that pushes to get into the land. And it's clear that there is a kind of trade-off between these two fluxes. But if you have a climate oscillation which translates into lower than usual precipitation, then you have a weakening of the freshwater flux, which means that it's easier for salt water to get in. We will prove this mathematically, but I just want to make clear, because this is the first step that you always have to make. Before studying a problem in math terms, in engineering problem, you have to understand how it works. And I want to make clear that there is this trade-off which we can perceive. It's something that it's indeed happening. So if we move further right, we get other two phenomena, which are climate change, which of course translates into sea level rise. Again, it may translate in reduced precipitation. And then we have subsidence, which is or uplift of by tectonic movements, uplift of the land. And this is changing the equilibrium profile, again, between freshwater and saltwater. Let's look at the second graph, the other scale. And these are more human-induced phenomena. And also the other ones were human-induced, because if you think about climate change, it is human-induced. If you think about droughts, it may be also human-induced, because sometimes droughts happen because there is a large consumption of water by humans. Now, let's look at these phenomena, which are more, let's say, human-induced. And so there is land drainage. Why land drainage is affecting? Precisely for the fact that it's inducing a kind of drought. It is reducing the strength of groundwater bodies. Because if you drain a land, usually you result in less infiltration. And then there might be accelerated subsidence, accelerated for instance, oil pumping, groundwater pumping, groundwater abstraction. Of course, if you take water from the groundwater bodies, then you reduce the strength of the groundwater body itself. You reduce the flux of water to the ocean. River modification is affecting, because river modification usually translates once again in reduced infiltration. Because when we modify a river, typically it's because we want to confine it. We want to confine it for facilitating navigation, for protecting us against floods. We want to confine it for getting more room for expanding our urban areas. And therefore, by confining a river, you typically increase the flow, increase the velocity of the flow. Increasing the velocity, you reduce infiltration. Land use change also may translate into reduced infiltration, which means increased saltwater intrusion, and then also exacerbated climate change. With exacerbated climate change, we refer to the urban areas, for instance, where there is an heating due to the heat island effect, which may translate again in increased evaporation and reduced strength of the groundwater body. Okay, this is a qualitative analysis, and here in this figure you see a schematic of the equilibrium between freshwater and saltwater. Let's look at this figure, because it's a first aid to get a perception of how human impact may have an effect on this equilibrium. So what happens here? Here you have in dark blue saltwater, in light blue you have fresh water, in between you see that there is a kind of color in between, which is a little bit gray, okay, gray with varying tonalities. This is mixed water, which means water with higher salinity than fresh water, lower salinity than seawater. Okay, and you see that there is a trade-off, an equilibrium. Okay, so close to the coast, you have in the sea water with typically a salinity that is lower than offshore. It's lower because you have fresh water entering from the rivers into the oceans, and it's diluting the salinity. Into the river, usually what you get, it's water with some higher salinity than the normal value of fresh water, because you have some mixing also into the river. Now, what you see is, if you look at this at the, let's say, right part of the figure, upper and lower, you see that at the interface between salt water and fresh water, there is the sea bottom. You see that there is the sea bottom degrading towards the right of the figure, and then you see that there are two wedges. Just 1 second, I want to copy the image and in a graphic table so I can draw on it. Just 1 second. Okay. Very good. Okay, let me draw on it. Little bit lower dimension, otherwise it's too large. Okay, here you see the sea bottom. Okay, it's appearing as a red line on the screen. And you see that there are these two wedges which I am highlighting in yellow. I am highlighting in yellow this the left limit of these two wedges. Just 1 second, it appears now. So what are these two wedges? These are the wedges of saltwater intrusion. So this is salt water that it's intruding into the land and it's competing with fresh water. And usually there is a mixed zone, which I highlighted in yellow, which represents the limit of the salt water wedge. We call it the saltwater wedge, which is the extent into the land. The wedge is the extent, the volume of land which gets intruded by salt water. The separation, the separation line in yellow highlighted there, we assume that it's more or less a sharp surface, a sharp line in this cross section. Actually, there is a mixing zone, but we will assume, for simplicity in our treatment, that there is a surface of separation. And what we want to do from a mathematical point of view, from a professional point of view, is to study the position of this separation surface, which in a 2D graph becomes a line, as you see here, a yellow line. Now, if you reduce the volume of the fresh water areas by pumping, and you see, now look at the figure, the bottom figure, you see that there are wells here, and these wells, I am highlighting just a couple of them. These wells, now my highlights will appear on your screen. These wells may take water from the upper aquifer. You see that there are two aquifers in this figure. There is one aquifer which is in contact with the river, and it's located at a higher elevation. And you see that the yellow well, which I highlighted on the right, is taking water from this upper aquifer. Below it, we have a confined aquifer. And you see that the left yellow well is taking water from the confined aquifer. So you may have wells taking water from the aquifers. The result is that the strength of this aquifer is weakened. The result is that their level, for the case of the upper one, is reduced. The lower one, the level is not reduced because it's confined, but still, if you take water from there, you reduce the energy of this aquifer. In the upper aquifer, you see the result of the reduction of the energy as decrease in level. And correspondingly, correspondingly, you see that the wedges are expanded. So if you look at the wedges now, I am highlighting them again in yellow. You see that these wedges are expanded with respect, the wedges in the low figure are expanded with respect to the situation that you can see in the upper figure. And they are expanded because we have weakened with human intervention, with pumping, the strength of the aquifers. So this is the phenomena that I would like to study. Now let me close this graphic window and let me go back to my web page. Okay, let me just log out from here, because if I log out, it's give me 1 second that I go back. I gain some room on the screen. Sorry. Here it is. Okay, good. Just wait 1 second, that is getting back. So after this qualitative discussion, let's talk of modeling. Okay, here there is another figure which is handmade by me. It's a little bit less clear because the colors are not very different from each other. But you can see in this figure there is again depicted the previous situation. You have the sea on the right with the dark blue, and you see the groundwater wedge, which is affected by, the position is affected by pumping, but not only pumping, also by natural fluctuations, natural drivers like for instance evaporation, transpiration from the plants, etc. And on the other side, on the left, you see that the food for the groundwater bodies is given by precipitation, infiltration, etc. So you can understand that droughts, situation with scarce precipitation, undoubtedly can, without any doubt, can lead to a change in saltwater intrusion. Now we have to study the position of this separation surface between saltwater and freshwater. Okay, now let's, before we make a break, let's set the basis. And in order to set the basis, let's start with recalling us what is and the meaning of the hydrostatic law. Okay, so let me get my graphic board, and I want to make a drawing to remind you what is the hydrographic law. So just 1 second that I put my graphic board in horizontal position. Here it is, and let me start my graphic window. I just want to make a very simple drawing before we break. Okay, give me a second. Here we are, and let me change my screen sharing to, let me change my screen sharing to the other screen. Okay. One second. Good. So I need to change the screen sharing. 1 second. Okay. Okay. Let me just check that everything is working fine. Yes, it's working. Very good. Good, now you see it. Perfect. So let's talk about, as I said, the hydrostatic law. And I take to you 5 minutes to remind it, and then we go for a break. So what is the hydrostatic law? The hydrostatic law, as the term says, refers to a static condition, but the static condition, which implies absence of flow of water, because hydro refers to water. Okay, hydrostatic means water that is not flowing because it's static. However, if you think of an aquifer, the aquifer is not static because the water in the aquifer is flowing, but it is flowing very slowly, as we said. And therefore, given that it's flowing very slowly, we can assume that it's in static conditions. For technical purposes, we can neglect the velocity of the flow. The velocity of the flow, keep in mind, that is of the order of magnitude of millimeters per second, from millimeters per second to centimeters per second. But centimeters per second in a groundwater flow is already a very huge velocity. Usually you have a very reduced velocity, and therefore you can assume that is, for practical reasons, it's zero, so it's static. And this is why I say that to study aquifers, to study what happens in the groundwater, what happens in the underground in terms of water flows, it's extremely important that you understand the hydrostatic law. So in order to study the hydrostatic law, let's refer to the very simple case of a tank. Let me see the yellow, I don't like it. Let me change the color for now. Okay, good. So let's refer to a tank, and let's suppose that you have a tank with some water into it. So you have a water level, and let's indicate this water level with the symbol capital H. Okay. Perfect. And now let's refer to a fluid particle into the tank. So let's suppose that I have this fluid particle here, and let's indicate with the symbol, sorry, let's indicate with the symbol H the water depth above the particle, while with Z we indicate the elevation of the particle with respect to a reference level. And the reference level, let's take it as the bottom of the tank. So you can see already here, from here, that Z plus H is equal to capital H. Okay, fine. Now let's indicate with the symbol P the pressure over this water particle. The pressure is given by the above water. So you have a water column over the particle, which has a weight. Okay, and this water column is pressing the particle. The pressure over the particle P is given by the specific gravity of water, the specific weight, let's indicate it with the symbol gamma, times the water depth above the particle. Okay? Now, what does it say, the hydrostatic law? The hydrostatic law says that if you sum Z plus pressure divided by gamma, this is a constant. Is it true? Let's prove it. It is for sure true, because if you substitute for P here, so if instead of you substitute here P with this expression above here, which I highlighted in yellow, it's a bit slow, but okay, now you see it, then you obtain Z plus, so P is gamma H divided by gamma, and then let's write constant, but this constant is still to demonstrate. Now you see that H and H annihilate each other, so from here we get that this is equal to Z plus H, and Z plus H is equal to capital H, so it's indeed a constant. So this is the hydrostatic law. So what does the hydrostatic law say? So let's remind it. this is the hydrostatic law. Okay, this is the hydrostatic law. This is extremely useful because it allows you to say that within an aquifer, we assume that the aquifer is in hydrostatic condition. You have within the aquifer the validity of this law, which means that, again, I write it again, Z plus P divided by gamma is equal to capital H. So basically, if this is, for instance, a free aquifer, a non-confined aquifer, capital H is the water level within, with respect to a reference plane. And therefore, you can say that in every particle, in every red particle, fluid particle, into the aquifer, the sum of the elevation of the particle Z plus pressure divided by gamma is everywhere equivalent to the water level of the aquifer. This is extremely useful and allows us to compute in any point of an aquifer the pressure, because this is the practical usefulness of this law, that we can compute pressure P, which I highlighted in red. Okay. Now, why it is useful? Because since the start of this lecture, we are talking about equilibrium between fresh water and groundwater, and salt water. Equilibrium between fresh water and salt water. Equilibrium is dictated by pressure. In order to study the equilibrium, we need to be able to compute the pressure into an aquifer, and we compute the pressure with the hydrostatic law. Okay, let's break 5 minutes now. Okay, in 5 minutes we see each other here. Meanwhile, I am here. If you want to ask questions on the chat, this is perfect. Good. Okay, so now we got acquainted with the hydrostatic law, and let me go back to the web page. Here it is. Okay, now, as I said, we make reference with the hydrostatic law to the static condition. Actually, the groundwater flow is strictly speaking, we said that it can be assumed to be static, but actually it's not really static. If we are interested in modeling, I am expanding the font, just 1 second, I see that it's still low, but anyway, it will come. Okay, good. If we are interested in modeling the flow in the aquifer, actually we need to remove the assumption of zero velocity. If we want to study the movement of water in aquifer, what we have to do is actually use the Darcy Law. The Darcy Law is the law that allows us to describe the conservation of energy in a groundwater body. And the conservation of energy, if we couple it with the conservation of mass, allows us to fully describe, as we know because we studied the groundwater flow equation, allows us to study the movement of the flow. We are not focusing on the Darcy Law here. We already talked about it a little bit when we studied the deductive models for assessing water resources, and therefore I'm not recalling it here. Actually, we didn't study the Darcy Law in detail, but I'm not really interested in going into the details of it. For studying the saltwater intrusion, let me continue to assume that everything is static. I just wanted to mention to you that if you want to make, strictly speaking, a refined analysis, you need to study the Darcy's Law, which is here. But I don't want to go into the details now. So now let's again assume that everything is static. And let's now focus on the equilibrium then in static conditions between salt water and fresh water. And in order to do that, let me focus on, just one second, on this scheme, which, just one second that it comes. Yeah, on the scheme that you see on the screen now. So basically we have this interface, which is the black line between the aquifer on the right and the sea on the left. And let's now look at another scheme here. Just one second, I get it. Okay, now this scheme, let me open it in my usual graphic window. Sorry. Paste. New image. Okay. Okay, here we are. Now what I want to do here is, just one second, that I wanna use a zoom that is a bit less magnified. Okay, now it's fine. Okay, what I want to make here is to study the equilibrium between this surface that you see now in red. This is what you see in red when it comes on the screen. It's the surface of separation between salt water and fresh water. It's coming now. So my purpose is to determine the position precisely of that surface of separation. Let's look at the details of this graph. So in black here I am depicting when it comes to the sea bottom. Okay, you already see it. And then when you get into the land, now I am depicting in black again the level of the land. Okay, perfect. Now I am highlighting the sea level. The sea level is here in blue. Okay, this is your sea level. When you get into the land, I am now depicting in blue the groundwater level. The groundwater level, of course, it's lower than the level of the land. Okay, now you see it in blue. And so let's focus on a full understanding of it. Let's try to fully understand. We have then the sea here. This is water, which okay. There is now a blue circle to indicate, and this is the sea. I am now putting some marker on it. And then in gray here, you have the salt water. So this I'm writing, so you see much better. This is salt water. okay? While on the right, I am overwriting, you have the fresh water. I am overwriting in blue so we can make sure that we fully understand. Okay, one important thing. These two water bodies have a pressure and therefore are pushing. The fresh water is pushing from the right to the left to get into the sea. The salt water is pushing from the left to the right to get into the land. At a certain point along the red line, they are in equilibrium. What does this mean? It means that they are pushing with the same pressure. And therefore, by imposing equality of pressures, I can study the position of the red line. Okay? Keep in mind that the water is pushing. Do you remember our previous, just one second, our previous statement? The pressure with which water is pushing is equal to the product of the specific weight of water. Now it's coming, what I'm writing, times what I indicated with lowercase h, which is the water depth above a given fluid particle. Now it's coming, just one second. Yeah, it's there. Okay, so you can also write this relationship by substituting gamma with the product of the specific of the mass density of water times G, and then times H. Okay, so gamma can be written as the product of mass density times G. Good. One important thing. What is the mass density of water? It's different between salt water and fresh water. So let's indicate, and I'm rewriting in red with Rho S, the mass density of salt water. I am writing on the drawing in red. And let's indicate with Rho F, the mass density of fresh water. You know that Rho F, it's about 1,000, kilograms per cubic meter. Salt water is heavier. Rho S, of course, Rho S depends on the salinity. We usually take, for an average salinity, we take Rho S equal to 1,024 kilograms cubic meters. Very good. This is important to take into account because it's a disadvantage. The fact that salt water is heavier, you see that it translates, if you look at the red relationship on the right, it translates into a higher pressure. Okay? Now, at the equilibrium, you must have that the two pressures are the same. So let's study, for instance, the equilibrium here of this particle here, which I am highlighting. Okay? Okay, now you can see it. If I want to study the equilibrium of that particle, I can write, I write in the upper part of the blackboard now, I can write that the two pressures are equivalent, and therefore I can write that Rho S G times, which is gamma, it's the gamma of the salt water, times H, capital H, because the height of salt water above this circular fluid particle that I am studying is capital H. This must be equivalent, equality of pressure, to Rho F G height of freshwater HF. HF is here. HF on the right. I rewrote in red. This is the equilibrium that I have to study, which means that in a way, what is my unknown? My unknown is lowercase hf. Okay, I know everything here. If you look at this relationship that I just wrote in the upper part of my figure, I know everything. I can say that G and G go away. So let me rewrite it. In order to rewrite it, let me expand. I have to expand the surface. So let me see. Okay, good. Good. I took some more room here. Just 1 second. Because I want to put a background here. Perfect. Okay, so let me rewrite this equation by writing, sorry, I forgot to take the pen, by rewriting rho s times capital H is equal to rho f times HF. I can rewrite it as H plus capital H plus lowercase h. What is lowercase h? Lowercase h is the elevation of the groundwater body, the elevation of the aquifer over sea level. Let's assume that this is a phreatic aquifer, unconfined, okay? Because otherwise, if it is confined, you should take in the value of lowercase h as the water level into a well, okay? But let's suppose that it's phreatic, so it's simpler, okay? So what is our unknown here? Our unknown, again, it's precisely lowercase h. This is what we want to estimate in this relationship. It's coming, just 1 second. I highlighted in blue in this relationship the value of lowercase h. Okay, now let's just develop, let's make some mathematical development. I can rewrite the same relationship as rho s times uppercase h is equal to rho, sorry, I think I can write rho f big H plus rho f lowercase h. Very good. Now let me rewrite it in this way. Rho f times lowercase h is equal to rho s big H minus rho f big H. Okay, it's coming. So I can move forward and write that this is equal to big H, which multiplies rho s minus rho f. Okay, it's almost there. Now I can go down and write that finally h, lowercase h, is equal to big H times rho s minus rho f divided by rho f. So this is the expression I ended up with. I want to make sure that you can see it. I think it's almost there. And in numerical terms, what does this mean? So you see the expression now. What does this mean? So let's again suppose that rho f is 1000 and rho s is 124. So this is more or less equivalent to big H, which multiplies 1024 minus 1000 divided 1000. Okay, let me see if you can see it. Yes. So this is equivalent to more or less, sorry, more or less, it's 24 divided by 1000 big H. Which means that it's more or less 1 over 40 big H. Let's see. Okay, you should be able to see everything now. Okay, let me see if in the web page I have got the same result. I just wanted to make sure. Let me see. This is again what you... Just 1 second. I have to find the right window. So it's not this one. Let me see when I get it. Okay. Give me 1 second. Okay, here it is. I can't get back the web page. Oh, okay, this is the web page. Let's see if I got the same result. Just 1 second. I have to go up, not down. Yes, the result is the same. The result is, once that you get it, you see the result is actually the inverse. Capital H is equal to 40 lowercase h. Okay, let me go back now to my figure, which is clearer, I think. Okay, let's wait that you get it. So what we obtained is something that it's a bit counterintuitive and it's a bit surprising if you think of it. So it means that if you have a small change if you have a small change in capital H, or it means that you have a big change of the position of the surface. I mean, the fact that you have the elevation of the aquifer above sea level is equal to 1 over 40 of the elevation of the sea level. It means that actually if you change the elevation of sea level of 1 centimeter, let me rewrite this as it is written in the web page. Capital H is equal to more or less 40 lowercase h. So what does this mean? It means that now you see the relationship that I am now circling with the blue line, which is the one that is in the web page. I am waiting for the blue line to appear. There it is. It means that let's suppose that you have this figure, which is the reality. Okay, it's the reality in the underground. Basically, if you change the sea level 1 centimeter and you want to keep the same situation, then you need to increase the level of the aquifer 40 centimeters. Which means that, I mean, if you have even a small change in sea level, in order to balance it, you need a much higher change in the level of the aquifer. And the reason is that there is this difference in weight, which is making a big difference. And this is why I say, look, 15 centimeters of sea level rise in the past 150 years, I don't think it is very relevant for coastal flooding, but for saltwater intrusion, yes, it is, because it means that if I want to keep the same position of the groundwater wedge, given that the sea level is increased 15 centimeters, I need to increase the groundwater level of 15 times 4, which means a lot. I mean, times 40, which means a lot. It's 4 meters, something like that. Okay. So it's indeed this computation that we did clarifies that saltwater intrusion is something that we have to be very careful of, and the sea level rise is something that we have to be very careful of. But let's forget about sea level rise. If you think about groundwater pumping may decrease the level of the aquifer significantly, which means that the position of the ground of the salt wedge changes a lot. And so you can understand why pumping provokes intruding, why sea level rise provokes intruding. You can fully perceive this, because the reason is precisely the fact that this is a delicate equilibrium. And this is my final conclusion. This computation explains to you that this is a delicate equilibrium. Okay, now, here we are. And in the web page, you find the same computation. If you go up, you see these steps, these mathematical developments here. It's the same computation that I did on the graphic table. Perfect. Now, this is called, this equilibrium condition is called, if you look at the caption of the figure, the Badon-Gibbon-Earthwork Principle, which basically dictates the position of the fresh saltwater interface in an unconfined coastal aquifer. It is a coarse approximation actually what happens, because of the many assumptions that we did. And in particular, it is worth considering that the assumption that we did, that the separation is a sharp separation, it's inconsistent. What happens in reality is that you have a mixing zone, you have a kind of large interface, which makes the problem even more concerning if you think of it, because it means that when you have saltwater intrusion, it's not a sharp phenomenon. It's not something that suddenly you realize that the water of your well became salted. It's a progressive increase of salinity, and which needs to be monitored, of course, and monitoring must be rigorous, must be very precise, because it's something that it's not easy to monitor. Okay, so here there is a figure where you can see this. There is what is called a zone of dispersion, and the zone of dispersion is actually this mixing zone I meant before. And now the question is how can we manage this? How can we remediate an aquifer that became salted? First, let's recall what are the causes, because if we have in mind what are the causes, then it's easier to identify the solution. So there is sea level rise, change in precipitation, I mentioned it before, increased evapotranspiration, because this reflects on the strength of the groundwater body. And then we have subsidence, local climate change, urbanization, change in soil permeability. So if you in a way urbanize an area, this is changing permeability, it's reducing infiltration, and increased consumption of water. This is another human impact which is effective on water pumping. Here we have other figures which quantify the same concepts. So be careful of groundwater pumping. And let me say that in terms of controlling saltwater intrusion in terms of driving it, actually our experience shows that groundwater pumping is a very relevant driver. Where you have wells, where you have water supply systems that take water from the underground close to the coast, you have to be very careful because this is the real driver. If you have wells, of course, the real driver, because it is groundwater pumping, it is indeed much effective on groundwater levels, even when you have a strong aquifer like the one that we have in this region, in Bologna, in Forlì, Cesena, Rimini. The aquifer is a large aquifer, a lot of water there, but when you start pumping groundwater, you see the level of the aquifer going down like 5, 6, 10 meters, because it takes time to replenish, it takes time to recover after a pumping, and it's a huge change. So this is the reason why I say this is the real driver you have to be careful of. Okay, now what can we do then? And also here there is another figure which is emphasizing again this phenomena. There is a lot of things, a lot of references on the web, because saltwater intrusion in many regions of the world is a matter of concern. Now, what can we do? And first, we have to get information, we have to get data, and monitoring. Monitoring is the first step. You have to monitor sea level, groundwater level, and salinity. Salinity is essential. If you have wells, you have to monitor their level and you have to monitor their salinity. Together with other water quality parameters, you can monitor also the nitrates. Today we have sensors in order to monitor wells that are very advanced. They are simple to use. They can transmit with the Wi-Fi, with the GSM, and they can deliver a lot of parameters related to water quality, salinity, etc. I want to give you an example of the monitoring program that we have in the delta of the Po River, close to Ferrara. And you see there these symbols that look like symbols of the euro are monitoring points where they measure the salinity. Also, they measure the salinity into the sea because they want to see who is prevailing. Also, measuring the salinity of the sea close to the mouth of the river allows you to see whether the river flow prevails on the water, on the sea currents, on the sea waves, or the opposite. Actually, what you usually see is during the wet season, you see that the salinity is decreasing in the river and in the sea close to the coastline. In the dry season, you have salinity intruding into the river. This is a problem because the river it's recovering quickly because the flow in the river, you know, it's quick, and the volume of the river, of the water body river, is much smaller with respect to the volume of the water body aquifer. And therefore the volume of the body compared with the velocity of the flow makes the river much more able to recover. But once that you get salt water intruding into the river, you may have infiltration from the river to the land, which is particularly the case of the dry season. In the dry season, it is the river feeding the aquifer rather than the opposite. And therefore, you know, if you get the river salted, then you get salinity intruding into the aquifer. And also there are monitoring points into the wells in the land, which are not depicted here, by the way. So monitoring is the first thing to do. Here you see a picture with color tones reflecting the level of salinity, and they refer to one day. And you see the legend on the left. It's August 9, 2012. And you see that there is also the color scale with the levels of salinity. And indeed, you see that this is summertime, it's the dry season, but you see that the salinity is going up quite substantially, and which means also infiltration, as I said. So it is something that needs to be carefully studied, and the monitoring programs precisely allow us to get the information that is required for studying them. And then once that you get all the required information, there is the question of the recovery. And first of all, you have to, as in any design problem, you have to clearly identify the problem. So what is concerning you? It's concerning you regarding the ecosystems. Are you concerned regarding water supply for civil use? And what is the reason of saltwater intrusion? Is pumping, it's subsidence. So it's extremely important. Remember, when you have a design problem, when you want to solve a problem, you have to identify the causes. This is why in climate change also we studied natural variability, because if we want to solve the problem, and in engineering, problem solving is costly, so it is not something that you can, take easy. And if you want to solve the problem, you have to identify the causes. This is the first basic step. So after you identify the causes and your targets, then there are several solutions. And let's say that as usual, it's useful to subdivide the solution into categories in order to better understand their meaning. And in particular, I think we can subdivide them in three categories. The first category is modification of groundwater and surface water withdrawals. So you act on the land, you act on the land, and you act on the water uses. And then a second possibility is if you modify the deliveries in terms of both recharge and deliveries to the water supply systems. Let me be clearer. Modifying the withdrawals means that I mean to say that we are changing the water sources. We are not acting on the demands. So instead of taking, for instance, what they did close to Rimini, instead of taking water from groundwater after a sharp increase of the demand, what caused the increase of the demand? Tourism. In the 70s of the past century, they had a strong development of tourism, and therefore they had an increase of the demand. They didn't want to act on the demand, or let's say they preferred not to act on the demand, because reducing the demand may have a commercial implication on tourism. They decided to, rather than taking water from the groundwater, they decided to build the Hydrostatic Dam and taking water from other sources. Actually, this helped a lot. The Hydrostatic Dam, which started working, if I well remember, in 1985, allowed them to push back the saltwater wedge significantly. This is a first solution. Basically, you change the withdrawals. The second category instead acts on the demand and reducing them. And another solution that may fall into the second category is that you try to increase the recharge of the groundwater aquifers by increasing infiltration, etc. A third category is use engineered structures. This is a solution that it's not easy, because it means many solution possibles, but the very hard solution that I mean to mention now is building an underground wall, maybe using jet piles or something like that, an underground barrier that stops salt water. It is a massive intervention. In some cases, it can be, in some cases, when the aquifer is not so large, it can be a good solution. And let's go into more details. Here you have a series of strategies that can be used. So if the strategy is to modify the groundwater withdrawals, you can, again, you can optimize the delivery, the water delivery. You can, for instance, change the irrigation strategies. And if you look at modified water deliveries, again, you can work on optimizing the deliveries. You can enhance groundwater recharge, as I said. And in the engineered structures, there are two subcategories which we may identify. The one that I mentioned before is to impede salt water, but we can also try to through engineered structures to increase the recharge. So we can increase, for instance, water delivery to the aquifer. We may take water, additional fresh water from neighboring rivers through river diversion, and we can try to increase the recharge of the aquifer. Now, I would say that that's it. Okay, so there are also references where you can get more information. I'm not going into the details of how jet piles are built, etc. And how to design jet piles, because I think sheet piles also, sorry, because also jet piles, it's a solution, but what is typically used to limit groundwater intrusion is sheet piles, which means that you put into the soil barriers in a way, either by injecting concrete or by fixing into the soil sheet piles, which are like iron barriers, which are joined each other, and in basically they build a screen in the underground which impedes saltwater intrusion. Okay, at this stage, I would say that we can make a longer break, 15 minutes, and then we take the last hour to make, as I said, a review of what we did together, identify likely questions at the exam, and I take your questions. And also I would like in this final hour to reach an agreement on how to organize and when your final presentation. Okay, and if you have any question, please write on the chat. I can either reply now or later on. Okay, students. Now, let me share the screen. Perfect. And let me share the other one. Okay, good. Perfect. Now, let me look at the chat. So we are 15, perfect. Good. 1 second, I'm looking at the chat. Okay, very good. So, let me go back to our page. Okay. Now, this is a list of the topics which we discussed together. I propose that we now open each web page, and then I have also to take notes. Just 1 second. Okay, I have a blank sheet. And then we review what we did. 1 second. Okay. 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 Good. Now, let's click on each of them. Okay. The first one, it's just an introduction, which you don't have to study for the exam. And let's make it clear what I'm doing now. Now we are discussing the questions and the topics that you have to study for the exam, which is a very specific discussion. And let's make it clear. There is no need to make it clear actually, but I want to be very, very, very precise on that. One thing is to get a good knowledge for improving your skills and get you prepared for your professional work. And another thing is to study for the exam. The two things are related, meaning that a good mark at the exam is a good indicator of the level of your preparedness, of the level of your skills. On the other hand, there is to say that this relation is not really one-to-one, which means that the kind of preparation that you get for the exam, as you well know, it's a preparation that is very specific for one day, which does not necessarily last for a long time. So it's very specific. Of course, when in the future you will have to prepare for an interview, the preparation is different with respect to the preparation for the exam. So preparing the exam is a very good exercise. It's a good thing for you because in any case, a good mark is not harmful at all. On the other hand, it's clear that it's a specific preparation for that day, which necessarily should be based on a larger base that you have to get in order to get prepared for your future. So this first lecture, for instance, which describes what are the skills that you should be careful of, which the skill which you should target. It's something that I believe it is very useful. So I'm not saying that you have to forget about it. I mean, but I'm just saying that for the exam, probably this is something that will not be asked. Okay. And so I'm not listing it as a possible reference for exam questions, but please make sure that in preparing for the exam you don't forget to get prepared for what is more important than the exam, which is your professional future. In any case, this description of educational methods and the description of skills is something that for the exam is not significant. So I go back, okay? Now, there is a second lecture in sustainability in the 21st century. It's the definition of sustainability, sustainable development. So at the exam, it may happen that I ask you some questions on this, which would be a descriptive question, like I could ask you just to start, or I could ask you as a brief question, something like, what is your idea of sustainability? How would you define sustainability? This is something that is very general, not really specific for this topic, but of course it may be a good question for me because it allows me to see if you have the big picture, if you really have a vision And of course, if you are very prepared on a specific question like saltwater intrusion, but then I ask you what is sustainability, and your reply is not very satisfactory, and this happens, believe to me, it happens, that some students and also some professors, some people in general, they don't have a good take of the big picture. So this is a lecture that is useful for me to get a vision of the big picture. And so I suggest that you don't forget about it for preparing your exam. So it could be, the question could be definition of sustainability. Another question could be, let me take notes because I want to take notes of what I'm telling you. And then another question could be, let me see. Yeah, the Sustainable Development Goals. So what are the Sustainable Development Goals? And you just have to say that these are goals fixed by the United Nations to be achieved by humanity within 2030. You don't have to learn by memory all the goals, of course, but the definition, what they are, this is something that is important. Okay, and I would say also the 3 pillars of sustainability. If I ask you what is sustainability, is nice if you mention the 3 pillars, okay, and their interaction. Okay, very good. Now, I would say that this is something that it's not really. Okay, water, food, energy nexus, what is it? Okay. Okay, just give me the time to write because I want to remind what I'm telling you. Okay, these statistics are not important. You don't have to really learn. You don't have to really learn them. But on the other hand, it's important that you have clear in mind that, for instance, the major source for our energy consumption is fossil fuels. It's something that allows you to get the big picture, okay? And also definition of sustainable water resources management and what is virtual water trade. This is another thing that may be interesting. These are questions that are not frequently asked, but it may happen that I ask them, okay? Okay, I would say, okay, let me go back. I think we are done for this. Now, let me look at sustainable management of water resources, third lecture. If you have any question, please stop me, okay? So let me see. I think here it's important again that you get some numbers, like 97% of the water in the globe is salt water. This is important that you know, okay? So distribution of water over the earth. But get the big picture, not really the tiny numbers, okay? Now let me see. I don't think that here there is. Okay, possible solutions for water scarcity, increasing water resources availability, reducing the demand, controlling the losses, etc., etc. Possible solution for water scarcity, okay, and then okay, I would say this is that's it. Perfect. Let me go back and then let me look at inductive methods. Here there are a lot of possible things that may be the subject of your exam. So what is the difference between inductive and deductive approach? inductive and deductive approach. Okay. Flow duration curve. What is a flow duration curve? This is a very frequently asked question. Okay, how to compute it? We consider two methods. So the two methods for computation. Be careful, this is frequently used. Also look at the details. And then, and then how to estimate variability of the flow duration curve, so estimation of this range that you can see here. Okay, and then there is this subdivision of the domains. Be prepared to discuss the flow duration curve. Estimation of design water withdrawal, so how to compute the volumes that from the flow duration curve that I can get from a river by taking into account environmental flow, etc. And also, what is environmental flow? Computation of withdrawal volume. And also there is environmental flow definition. Environmental flow definition. Okay. Perfect. And now let me go on. I think here there is nothing more to say. And okay, this is just how to inductively assess groundwater resources availability. It's just monitoring. Okay, it's just monitoring through wells. Okay, now let me go back. Deductive assessment. Here there is also a lot of things. So the linear reservoir, please. Also this integration here. It's the linear reservoir is something that is frequently asked with all the steps that you can see here. Try to remember them. Also this progress of river flow with constant rainfall. This is something that is frequently asked. What is a nonlinear reservoir? Okay. IMOD model. IMOD model is also frequently asked. It's a bit heavy in terms of mathematical development. Just be patient in learning it. And I think everything here is okay. Groundwater flow equation. So how it is derived. This is another question that is less frequently asked, but still it's sometimes I ask it. Okay, and perfect. Let me go back. If you have any question, just step in. Okay, don't be shy. And model calibration and validation. Here it's what are calibration and validation. Don't forget validation and objective functions. What are the objective functions? And remember them, please. We did only a few. The least squares, let me see here, and then dash efficiency, and the sum of the absolute error, and the sum of the absolute relative error. And please keep it in mind. Also, expert knowledge. So automatic calibration and expert knowledge. Very good. Validation. Okay, let me go back. Design of river barrages. A frequently asked question is, can you please draw a sketch of a river barrage? And can you please describe to me what are the design problems that we discussed? Okay, so just try to get able to draw a sketch of a river barrage, which is the sketch that is reported here. Just 1 second, it's reported here. Okay. The water withdrawal index and the water use index, water withdrawal index and water use index. Let me see if the terminology is precisely this, which I used here. Yes, water withdrawal index and water use index. I'm just waiting a little bit that you get it. I'm sorry. Where are? Here they are. Just 1 second. Okay. Okay, good. And then the how to design a sand trap without learning the Stokes formula. Without, I mean, it's not usually I didn't I skipped it and therefore usually I don't ask it. Here is. But I frequently ask how to locate the elevation, how to identify, how to determine the location of sorry, the altitude of the different traps. Just 1 second because I need to answer the phone. Just 1 second, please. Vane, sto facendo lezione. Ti sentiamo dopo. Grazie. Ciao ciao. Okay. So, just 1 second. How to design elevation of the withdrawal thresholds. How to design elevation of weirs. I couldn't get how to design the elevation of weirs. Okay, and let me see how to design the head tank. This very, I mean the also the Blig-Lane relationship. These very short empirical rules. Try to remember at least what they are, and if you can also remember, for instance, in the Blig-Lane relationship, if you can remember also how it's written down, it's useful. Okay, very good. Let me see. Design of river barrages, climate change and water resources. Look, it's very unlikely that I ask you questions on that, and just make sure that if we talk about it, I get the feeling that you had a look. I mean, I don't ask quantitative questions. Maybe that I ask something within other questions. For instance, if we talk about saltwater intrusion, I may ask you something like, in your opinion, to what extent climate change may have any influence on it? And therefore, it's I think it would be important, in order to provide your reply to a similar question, that you have clear what is the order of magnitude of sea level rise that we experienced so far. Of course, if you want to discuss the importance of climate change on saltwater intrusion, you have to know that. So this is just what I suggest you to have an idea of the orders of magnitude of climate change. Human impact, and so I'm not opening the page. And let me take a note. Orders of magnitude of climate change. Okay, and then assessment of human impact on water resources. I don't know why here there is a figure that is missing. I have to check for it. So let me see if it's only a visualization problem or not. Just 1 second, I am reloading. No, there is something wrong here. Okay, I will check. Let me take a note. Check. First figure, human impact. Okay, so human impact, we discussed this kind of proposed framework. Just please try to in this case as well, to get the big picture, okay, we may discuss, I may ask you something like, how would you assess human impact on water resources? And I'm not saying that you have to repeat what's written here, and but just to get able to discuss it, okay? Okay, and like, for instance, this discussion on priorities, etc., and an introduction to decision theory. In this case, I would say, if I had to reply to a question, how would you assess human impact, I would also mention a little bit decision theory, historical data analysis, climate modeling. This is something that I would get into play here. And here there is something on the linear regression, and just keep it in mind, okay? Because this may be a question for the exam. And I may say something like, look, we often use linear regression to estimate human impact on water resources. And what is linear regression? How would you perform it? So please be able to discuss what is linear regression. And also here there is the estimation of the parameters through least squares. And these are the issues that I suggest you to get prepared on. What is a linear function? Okay, this may be something that I ask. Here I wouldn't say that there is. Okay, this is okay. Let me go back. And then there is decision theory. This is another frequently asked question. And please be prepared to discuss on robust decision making and decision scaling and decision gap info gap decision theory. And so it's just something that you have to be prepared to discuss. And then there is the pairwise comparison, how to estimate the weights. This is something that I frequently ask. So I'm going down in the page here, analytical hierarchy process. So this is something that I may indeed ask. And pairwise comparison. Okay. Now let me go down. I don't think there is anything more that I should say here. Just get prepared and discuss very precisely this. And then saltwater intrusion, which we did today. Basically, I ask how to determine the surface of separation between saltwater and freshwater when dealing with saltwater intrusions. So you have to get prepared to discuss hydrostatic law, etc. Okay. So these are the frequently asked questions, and I just want to make clear the purpose of giving these hints, these suggestions to you. It's just to give you an idea of what my questions could be, and by all means, don't assume that I am binded to ask only these questions, of course. I may ask you something different, especially if you are good. If you turn out to be a very good student, I may ask something, questions which are more specific and maybe also a bit outside what I explicitly discuss with you. This is a possible mean for me to understand whether you are whether you made an effort to expand your knowledge, which is something that I value a lot. So I mean, I just wanted to make you comfortable by giving this review and this list of possible questions, but of course there are other questions that may be asked, and this is particularly important to keep into account. Keep in mind that all of this discussion is recorded. Let me see. I want to make sure. Yes, I am recording. So in the video, this review and these possible questions are there. If you want to refresh after maybe some time, if you postpone this exam, this discussion is recorded and will be made available to you. Now let's discuss briefly on our presentation day. So let me remind you what is the idea. The idea is by seeing that I think we enjoyed these presentations that you gave. At least I enjoyed them. And it would be also nice when you compile your survey, or if you let me know if you liked this opportunity, because we dedicated some time actually. I think it was not a problem because we were on schedule. I completed my program, and therefore, I mean, I think it was an interesting experience. But let me know maybe afterwards or when you compile your survey if you liked it. And given that it was interesting, the idea is why not to organize, and given that we have some time before the exam, which is a pity. It's a pity because I mean, I know that many students would like to to get the exam as soon as possible. But given that there is some time that we have to wait, the suggestion is that we meet half a day and I give you 12 minutes to make a presentation in PowerPoint. And the presentation may be something related to what you already presented, something more, of course, or maybe a new topic. It's your choice. And I would prefer that I mean, that is completely your choice. I may assist you if you want, but I would prefer that in this case you try to be independent. So if you have questions, very specific questions like what is the optimal number of slides, feel free to ask me. But I would prefer that you don't ask me an opinion on the content, an opinion on the technical level. Let's see what comes out. I think it's interesting that it's a work done by you. But this is not to say that you shouldn't ask me anything about it. So please feel free to ask. And then if I believe that it's too much, I tell you, no problem. But just make an effort to be independent because I think it is interesting as long as you are fairly independent. So you make a selection of the topic. I just wanted to make sure I gave you some suggestions like, sorry, Sam, I look at your question, just 1 second. Can you please elaborate on, 1 second. Can you please elaborate on what one question in exam may entail? For example, if you were to ask a general question about FDC, will further sub-question be regarded as part of that question? Yes, I'm not sure if I well understood your question, but let's assume that I ask you what is a FDC, and then you tell me what is, and then I may ask you how do you quantify uncertainty? If you didn't tell me when you replied, I may ask you sub-questions, and the sub-questions. I have not a fixed rule if a sub-question is a second question or not. And also, I have not a fixed rule on the number of questions that I may ask you. In some exams, I ask 2 questions. In other exams, I may ask 15 because sometimes the student is very sharp in providing the reply. Like, what is a flow duration curve? There are students that start talking and say everything. And in this case, I may leave the student to talk because I like to see whether the student is independent in delivering a synthetic presentation. But other students talk just 10 seconds, like the flow duration curve is a way to assess water resources availability. And then I may ask, okay, how do you compute it? And maybe the student just says the first method. And then I may ask, okay, there is another method. Can you please talk about it? And the student talks about the other method, but it doesn't say anything more. And then I ask, okay, what are the pros and cons of the first and the second? These are many questions, but at the end of the story, it's only one. It's the flow duration curve. So usually I would like to ask questions about 2 broadly different topics. So if I ask a flow duration curve, it's one topic. And if I ask 15 questions within the same topic, to me is one broad topic. And then it's unlikely that I conclude the exam without checking at least another topic. Ideally, I would like to check about 3 of them. And the number of questions is really something that it's not cannot be fixed. And another thing is I don't make an average of score for each question. So I don't think you should be concerned about the number of questions. The only thing that I can tell you, it's unlikely that an exam lasts less than 15 minutes, but it may happen, especially if the student is very good. It's unlikely that it lasts more than 30 minutes. And more than the number of questions, I think it's the timing that you have to take into account. And of course, in 30 minutes, one may ask like 40 questions or just one. It depends on how the student replies. So let me go back to the presentations. In the presentation day, if you decide to deliver a presentation, I'll tell you what is my assessment. Like, look, the presentation was outstanding, and or I may tell you something like was good, or I may tell you very good, or I may tell you so and so. So it's clear that outstanding means loud. Very good means 29, 30. Good maybe 26, 27, but I may tell you if you want, but I prefer in this phase not to talk about marks, because then if I give you a mark, you may imply that I'm making an average, which is not true, because I mean, at the end of the story, the evaluation of an exam, as I said, it's not an average among the questions, over the questions. And or may say so and so is 26, or I may say, look, this is something that really is not very good, and this means that probably it's better if you discard it. Now, depending on what I tell you, I will ask you at the exam, would you like to make a full exam, or would you like to take advantage on the presentation? And then, if you want to make a full exam, I completely forget about your presentation. If you tell me, no, I was happy with the experience, and typically the students say, look, professor, if you tell me that the presentation was very good, I would prefer to keep it. This means that I take into account your presentation, and my exam will be shorter, like 10 minutes, indeed. Okay? And I think it is a possible way for you to dilute the preparation for your exam. It doesn't mean that you can discard something at the exam. You at the exam are still required to prepare everything, but in a way it's a possibility to dilute your exam. But above all, I think it's an interesting opportunity for you in general, because preparing a presentation, I think it's a very useful exercise for your future commitments. So when can we make it? I think, let me check my calendar. So I think it's better if we fix the day already. I will also try to invite some colleagues. I'm not sure whether I will have time to attend, but at least for a part of it, I would like to invite some colleagues, because I think it is interesting for you if somebody else is attending. So I cannot before 18th of May. My preference would be to make it in the last week of May, but I could also, let me see, I could also make it on, let's make it on May 21st. No, May 21st in some countries is an holiday, so just let me know if you have any problem with it. If you don't have any problem, I would say, why not May 21st at 9:30 a.m. It will be about 4 presentations per hour, so I think the duration probably will be something like 3-4 hours, depending. So May 21st, 9:30, over Teams, of course. I'm just booking my calendar. 1 second. Okay, and I am also putting a reminder in my calendar. I'll on May 16 to send you a reminder on the chat. Just 1 second. Okay, because on May 16 I will send you a reminder on the chat. Okay. And now, how to subscribe to it, because I need to know who is presenting what. What is not really necessary, but who is presenting, yes. And so I suggest that we use the chat to discuss about this. So I think it is useful because in this way your subscriptions are also a reminder for the other students. So in order to book for it, please write on the chat that you are booking for the presentation and put the title there. If for some reason you have some communication that you would like to give to me confidentially, no problem, use the email, okay? Also in the chat, I think it's possible to send private messages, but let's not make it very complicated. Write on the chat for, let's say, public information and for booking. And if you have any confidential information, just send an email to me. So you book on the chat, and when to book, I would say I'm not fixing a deadline. I will send you a reminder on the 16th, and then let's say that don't book the last day. So just try to book at least 3 days in advance. The only reason for booking is that I need to know how many students are delivering the presentation. Please don't assume that delivering the presentation is for you something required in order to make a good exam. It's not absolutely that. You can get 30 with Laude without delivering any presentation. And if my suggestion is to take this opportunity, if you are really motivated to do that, for the sake of making something useful for you, but not useful for getting a good mark at the exam, useful in general. So if it's not something that you really need, and I would say that in terms of forming your mark for the exam, it's not a good idea if you deliver a very bad presentation. So what I'm suggesting to you is don't deliver a presentation without dedicating the proper amount of time. It requires some time. If you are willing to put it, your effort and your time, then it is useful also for your exam. If you make a presentation without getting very committed and a poor presentation, it's not a good idea. I would suggest you in this case to save your time for studying and don't rush over the presentations. I don't think what makes that day successful is the quality of your presentations. So my expectation is that today we will see very good presentations. And if you don't have time for many reasons, because there are many reasons and very good reasons for not having enough time, don't be concerned. You can just skip it, no problem. I hope this is clear. And as I said, I will send you a reminder. Okay, I think I am basically done. And I just want to say before giving the floor to you for any question. First, any question can be asked now, but also later. And you decide. You can write on the chat or the email, and just please be aware that for urgent communication, the email is better. On the other hand, for me, it's more comfortable if I get the question on the chat, because the email is sometimes flooded. So just be aware of the difference. If you write on the chat, I'm not forgetting it, but I may reply a couple of days later. And if you send the email and the chat, usually my replies are more informed. In the email, I am usually very brief. But if you have any question, you can contact me whenever you want. First premise. Second premise, or let's say more than a premise, is a thank you. I wanted to thank you because I was really impressed. And I tell you, this is not something that I say to all my courses. I was really very impressed by two things. First, your patience in adapting to this situation. Second, I was really impressed by your proactivity. I'm not sure whether this situation contributed to stimulate your proactivity. I can tell you that I am teaching another course and it was not the same. I think you really were very proactive and in many ways, and this helped me a lot. And in fact, I think with respect to the past years, I put on this subject more efforts to teach, to change my web page, to update them. And the reason was that I was very stimulated by you. So I'm really grateful to you for this because it was not an easy period also for me. Also in terms of teaching, it was not easy for me to make this experience. I'm still missing your eyes because I realized that not having the opportunity to look in the eyes of the students, it is not a good thing for me because now I realize that by looking at the eyes of the students, I can get whether my teaching was appreciated by them or not, whether I was clear or not. So I'm still very much missing it. And so it was not easy for me as well, but it was really helpful, your support and your commitment. I'm really grateful to you. I have no words to thank you for this. Okay, now, if you have any question, I can stay, no problem. If you don't have any question, we say goodbye, but for now, because we meet again in May, and then also we can stay in touch, at least remotely, it's not a problem as we have seen. Any question? Okay, I saw that some of you, okay, just 1 second because there are some questions. Okay, so Ludovic, unclear what we can do with the presentation we already made. And yes, you can do that. You can keep it and expand a little bit. So for instance, I told you that some more numbers would be helpful. It may be your decision also to keep more or less the same and just add a couple of slides. And also keep in mind that you could improve it in the way you present it. It's not only the PowerPoint. The PowerPoint is an issue for sure. So you need a good PowerPoint. But over a good PowerPoint, you need a good presentation. And a good presentation is by improving your speaking, which was already very good, by the way, but you can improve it. You can improve your preparation because, you know, one thing is also for professors. One thing is when one is prepared to speak, and the other thing is when you know the subject, but you didn't practice your speaking just before it. So it is also one way to improve your speaking. I hope I was clear. And in any case, you don't have to, just feel very free to see what could be a way to introduce innovation. And it could be in the PowerPoint, it could be in your way of presenting, it could be, I don't know, it just keep in mind that what is the objective of a good presentation is to deliver interesting knowledge in an interesting way, get the attention of people. So, for instance, if you look on the web, I'm not suggesting that you have to do it, but if you look on the web, how to prepare a good PowerPoint presentation, you find millions of references. There are people saying the max number of words to put in the slide, in one slide. There are people saying max number of figures. So, it is a very creative exercise, and I give you some suggestions, but I really would like that it's really up to you. And so, Maurus, the timing, I said 9:30, and I said, I think, basing on the number, it may last up to 12:30 or 1:30. I don't think we will go more than 1:30, but I will be able to tell you the timing in when I have the full set of people who booked. So if you need to know the time much in advance, just let me know. One thing that I didn't tell you, I really would like that you attend all the presentations. It's not necessary. I mean, if you have just a couple of hours free because you have another lecture or I don't know, and just let me know. It's not a problem if you leave. But I think I really would like to see it as a meeting also among us. So I see that there are many of you who already booked, and I think it's okay. No problem. It's already, I can already take it into account. There is no need for you to confirm. Other questions? Okay, students, if you don't have any other question now, I think we can close here. And again, thank you very much. I hope you enjoyed it, but I am also looking forward to your opinion on the survey. Don't forget the survey, okay? It's open up to Sunday. Very good. So, students, thanks a lot once again, and let's keep in touch for any question you know how to reach me. Grazie mille. Ciao.
Ciao.
I didn't get it.
Ciao, grazie.
Prego.
Ciao, ciao, grazie.
Prego.
Ciao.